Imagine for a second, just holding this totally standard, unassuming white plastic cube, like the kind of intermediate bulk container you'd probably see strapped to the back of a flatbed truck.
Right, carrying water or, I don't know, industrial syrup or something.
Exactly. Now, what if I told you that this completely mundane object, like sitting right in front of you, possesses the capacity to simultaneously stop 800,000 people from suffocating in their own kitchens every single year?
Wow.
And that it could literally revive billions of tons of dead, compacted earth across the globe.
Yeah, which is a massive claim.
It is, and perhaps most unbelievably, that it could take the raw, untreated human sewage that's currently choking our major cities and, well, transmute it into a multi-billion-dollar economic engine for the global south.
It sounds like magic, honestly.
Right. But today, we aren't talking about some distant science fiction or, some vaporware tech promising to save the world in 50 years. We are talking about cow dung, human waste, and a radical rethinking of how power, both electrical and geopolitical, actually works. Welcome to today's deep dive.
It really is a profound shift in perspective.
Yeah.
Because you are looking at waste not as a liability that has to be hidden or managed, but actually as the raw feedstock for a decentralized global utility grid.
Which is just a wild way to think about it. And we are pulling this together from some truly fascinating material today.
We really are.
Yeah, we're looking at a deep systemic analysis that was published on April 15th, 2026.
Right.
It's on a platform called Democracy for Nepal by Paramendra Kumar Bhagat. And, Bhagat is essentially dissecting this viral, highly detailed thread by Ruchit Jigar.
Who runs the Harvesting Farmer Network, right? The HFN.
Exactly, the HFN. And they are laying out the mechanics of how decentralized biogas is being mass scaled.
Okay, let's unpack this, because what becomes immediately clear when you read through these notes is that the core innovation here isn't just a new piece of hardware.
No, not at all.
It is a revolutionary business model layered over a highly optimized biological process. It's a total waste-to-wealth revolution.
It is. And, I love how these sources frame it, because if you followed renewable energy or international development at all, you are probably rolling your eyes right now.
Right. Like, oh, great, another biogas project.
Exactly. Biogas is not a new concept. People have been trying to make, poop to power work in rural India and sub-Saharan Africa for decades.
Decades.
And historically, it has been a graveyard of failed projects.
Yeah, so we have to start there. If the promise is so massive, why did past attempts at rural biogas fail so spectacularly? And, what makes this specific HFN Biogas Cube any different?
Well, to understand the breakthrough, you absolutely have to understand the historical friction.
In the past, specifically in India, the government heavily subsidized and promoted these massive permanent construction projects.
Okay.
We are talking about the KVIC floating dome or the Janata fixed dome models.
So these aren't just things you buy at a store.
No. If you wanted biogas, you didn't buy a product. You initiated a civil engineering project right in your backyard.
Right. You're digging a massive crater, laying brick and mortar, pouring concrete. It's a permanent piece of real estate.
Exactly. And they were expensive, often costing a farmer between 30,000 and 50,000 rupees.
Wow.
Which, that was a staggering upfront capital barrier for a rural family.
Yeah, I can imagine.
But the engineering itself was the fatal flaw here. When you bury a rigid masonry structure in the ground, it is subjected to soil settling, groundwater pressure, temperature fluctuations.
Mother Nature basically fighting it.
Right. And over time, those concrete domes develop microfractures.
Oh, I see where this is going.
Yeah, because the entire system relies on maintaining a strict anaerobic, meaning oxygen-free environment.
So any leak is disastrous.
The moment you get a hairline crack, the gas pressure drops, oxygen seeps in, the microbial colonies stall out, and the system literally dies.
Wow.
And because it's underground, finding and patching that leak that requires specialized technicians, the system essentially required its own high priests of maintenance.
That's wild. So you have this highly fragile system that takes weeks to build, costs a fortune, and brakes if the ground shifts even a little.
Exactly.
You know, it reminds me perfectly of the early computing era.
Oh, how so?
Well, think about those massive mainframe computers from the 1970s.
Oh, right. Yeah.
They took up entire rooms, they cost millions, they required specialized cooling and a whole team of white-coated technicians just to keep them running, and therefore only massive corporations or governments could actually utilize them.
That is a perfect analogy.
That is the masonry biogas digester. It's an exclusionary technology. But reading through the descriptions of this new HFN Cube, I mean, it's the smartphone. It's a modern plug-and-play appliance that totally decentralizes the power, you know, bringing it to the everyday user.
It really is. The HFN Cube strips away all that civil engineering. It is literally just a 1,000-liter heavy-duty plastic tank.
Like the IBC tanks.
Exactly. Enclosed in a protective metal cage, you just drop it in a courtyard, you hook up the inlet and outlet valves, and it installs in about 2 days.
2 days compared to weeks of pouring concrete.
Right. And it is entirely above ground, meaning you can visually inspect it.
It makes so much more sense.
And because it is a sealed industrial-grade plastic container, it doesn't suffer from those microfractures that plagued the concrete ones. If the farmer moves, they drain it, put it on a truck, and take it with them.
That's huge.
It's an asset they actually control.
But, you know, the hardware isn't even the most disruptive part of the smartphone analogy, is it?
No, not at all.
Because from what I gathered in the sources, the real barrier with those old concrete mainframes wasn't just the cost or the cracking, it was the feedstock. It was the sheer volume of manure required just to get the minimum pressure to push the gas through a pipe.
And this is where the economics of the HFN Cube completely rewrite the total addressable market. The old masonry domes require the daily dung from a minimum of 5 or more adult cattle just to function.
Which completely locks out the poorest people.
Entirely.
Because if you own 5 healthy adult cows in rural India, you aren't the poorest farmer in the village. You have significant capital.
Precisely. You are basically subsidizing a technology that only the relatively wealthy landholders could actually use.
Right.
But the HFN Cube, because of its optimized volume and that seal design we talked about, it only requires the daily dung from 2 to 3 cattle.
2 to 3. Okay.
Now, that sounds like a minor detail, lowering the requirement from 5 to 2. But if you map that onto the demographic reality of India's agricultural sector, it is a tectonic shift.
Because most people don't have huge herds.
Exactly. There are over 120 million small and marginal farmers in India. The vast majority do not own a massive herd. Right.
They own a couple of animals to supplement their income and their diet. By scaling the technology down to fit the reality of the median farmer, you fundamentally change who gets to participate in the energy transition.
Okay, so we've taken this fragile, expensive mainframe and turned it into an accessible, rugged appliance. But let's actually look under the hood, or I guess inside the plastic cube.
Sure.
If I'm a listener who knows, how a backyard compost bin works, I understand that organic matter breaks down over time.
Right, naturally.
But how are we optimizing that breakdown to yield a volatile, flammable gas? Because taking cow manure, putting it in a plastic box, and getting literal fire out of the top, it feels like alchemy.
Yeah, it does.
Explain the mechanics for us. How does this microplant actually function day to day?
Well, it is alchemy, but it's biological alchemy. We are essentially domesticating a microbial ecosystem that has existed for billions of years. The overarching process is called anaerobic digestion.
Okay.
Now, when you compost in your backyard, you turn the pile to introduce oxygen, right? You want the air in there.
Exactly. That's an aerobic process, which produces heat and carbon dioxide. But in the biogas cube, we are completely starving the system of oxygen.
Because oxygen is toxic to the specific bacteria we want to cultivate here.
Exactly. So here is the daily operational loop. The farmer takes the fresh dung from their 2 or 3 cows and mixes it with an equal volume of water.
So a 1-to-1 ratio.
Yeah. And this creates a homogeneous slurry. They pour this slurry into the inlet pipe, which feeds into the bottom of the sealed cube.
Okay, so it goes in the bottom.
Right. Inside that pitch-black, oxygen-deprived environment, this highly complex 4-stage biological warfare unfolds.
Biological warfare, I love that.
You have hydrolysis, acidogenesis, acetogenesis, and finally, methanogenesis.
Okay, wait, let's break that down because I really don't want to get lost in the textbook terms here.
Yeah.
What are these microbes actually doing to the slurry?
Fair enough. Think of it like a biological disassembly line. First groups of bacteria. They break down the complex carbohydrates, proteins, and fats in the dung into simpler sugars and amino acids.
So they're doing the heavy lifting first.
Right. Then the next groups take those sugars and ferment them into volatile fatty acids.
Okay.
And finally, the star of the show, the methanogens, they feast on those acids. Now, methanogens are archaea, which are some of the oldest living organisms on Earth.
Wow. Okay.
As they consume the acids, their metabolic byproduct is a gas. They essentially exhale a mixture that is roughly 55 to 70% pure methane.
That's CH4, right?
Exactly, CH4, with the remainder being mostly carbon dioxide and just a trace amount of hydrogen sulfide.
And because methane is a gas, it's lighter than that dense liquid slurry we poured in at the bottom.
Right.
So it just naturally bubbles up to the top of the cube. There's no mechanical pump needed to harvest it, is there?
Not at all.
The pressure of the gas itself just pushes it out the valve at the top, straight through a pipe, and directly into the farmer's kitchen stove.
Precisely. And, this is where the genius of the physical design really comes in. The process is highly sensitive to thermodynamics.
Oh, the temperature.
Yeah. Methanogens thrive in what we call the mesophilic temperature range.
Which is what, exactly?
That's between 25 and 35 degrees Celsius.
Okay.
If it gets too cold, they just go dormant. If it gets too hot, they die. But conveniently, 25 to 35 degrees Celsius is the standard ambient temperature across vast swaths of rural India, sub-Saharan Africa, and the broader global tropics.
So you don't even need a heater.
No. The environment naturally provides the exact thermal envelope the microbes need to operate at peak efficiency.
That is incredibly elegant. Now, I do have to step in and push back on the actual yield here, though.
Sure, Vadi.
Because the sources claim that this 2 to 3 cow system generates roughly 2 to 3 hours of cooking gas per day.
Right.
Now, to someone sitting in a modern apartment with a gas line that runs 24/7, 2 hours of gas sounds, frankly, incredibly underwhelming.
I get that.
I mean, is that really enough to change a family's economic reality, or is this just a marginal improvement being marketed as a revolution?
Well, this raises an important question, right? How do we measure impact?
Right.
Because it is an absolute revolution, and to understand why, you have to look at what that 2 to 3 hours is actually replacing.
Okay, what is it replacing?
From a purely economic standpoint, 2 to 3 hours covers more than 50% of a typical rural family's daily cooking energy needs.
Okay, half their energy, that's not bad.
Right. And the immediate financial impact is that they drastically reduce their reliance on imported liquefied petroleum gas, or LPG.
Those big metal cylinders.
Exactly. Those heavy LPG cylinders are incredibly expensive. Their prices fluctuate constantly with global crude oil markets, and transporting them to remote villages adds a massive logistical markup.
So by having this cube, they are essentially printing their own currency to offset their highest household utility bill.
Yes, exactly. But honestly, the economic savings pale in comparison to the public health reality. Oh, absolutely. When rural families cannot afford LPG, what do? They forage for biomass, they burn firewood, crop residue, or dried dung cakes in open indoor hearths.
And the smoke from that is lethal.
Lethal is not hyperbole. The sources point to a staggering, just devastating statistic. There are 815,000 premature deaths every single year due to household air pollution.
815,000.
Every year. And it's overwhelmingly concentrated in Africa and Asia. We were talking about women and children spending hours every single day inside unventilated kitchens, breathing in thick, toxic smoke.
That is horrifying.
It is. And it's heavily laden with PM 2.5 particulate matter, so small it bypasses the body's natural defenses and lodges deep in the pulmonary alveoli.
So that's nearly 1 million people dying annually just trying to boil water and cook dinner for their families.
Exactly. It is a slow-motion public health catastrophe that goes largely ignored because, well, it happens behind closed doors in impoverished communities.
Yeah.
So when you ask if 2 hours of gas matters, the methane produced by this cube burns completely clean. It produces a crisp, blue, smokeless flame.
Wow.
When you install this cube, you are quite literally removing the equivalent of smoking multiple packs of cigarettes a day from the lungs of a child. You are intervening in a medical crisis using an energy appliance.
That completely reframes the entire technology for me. We aren't just talking about off-grid energy anymore. We are talking about preventative respiratory medicine on a mass scale.
Exactly.
But this brings us to a massive structural bottleneck. I mean, the technology works, the health benefits are clearly undeniable, the household economics make sense.
Right.
But I'm sitting here looking at a global crisis, hundreds of millions of people relying on biomass, an entire planet needing to decarbonize. We can't just hand out plastic cubes one by one and hope for the best.
No, we can't.
How do we actually scale this? Because the logistics of distributing, financing, and maintaining millions of these individual units across thousands of disconnected villages, I mean, it sounds impossible.
Well, it is impossible if you treat it as a traditional consumer retail product.
Okay.
And this is exactly where the source material introduces the true engine of this revolution, the Amul model. We basically have to pivot from the biological mechanics to the socioeconomic mechanics.
Right. And for you listening who might not be familiar with Indian economic history, Amul is arguably one of the most successful cooperative business models in global history.
Without a doubt.
Give us the crash course. Why are the sources so obsessed with a dairy company when we are talking about biogas?
Because the underlying structural problem is identical.
How so?
Look at the Indian dairy sector in the 1940s and 50s.
Right.
You had millions of incredibly poor, highly fragmented farmers. They each had maybe 1 or 2 cows.
Okay.
They produced milk, but milk spoils quickly. And because they had no refrigeration, no aggregation, and no transport, they were entirely at the mercy of predatory middlemen.
Right.
The middleman would show up at the village, offer pennies on the dollar for the milk, and the farmer basically had to accept it or watch their product rot. They had zero leverage.
So the farmers were carrying all the risk of maintaining the livestock, but the middlemen were extracting all the capital value from the actual product.
Exactly. So the Amul cooperative was formed to ruthlessly eliminate the middleman and shift the leverage back to the producer.
I love that.
They built a highly disciplined 3-tier structure. Tier 1 is the village-level society. All the farmers in the single village pool their milk every morning and evening.
Okay, so it starts local.
Very local.
Yeah.
Then Tier 2 is the district union. The village societies send their aggregated milk to a district-level processing plant that the union owns. They pasteurize it, chill it, package it.
Got it.
And finally, Tier 3 is the state federation, which handles the marketing, the branding, and the national distribution.
So by aggregating everything, they suddenly have the sheer volume to justify building massive processing plants, and they have the capital to build a proper cold chain logistics network.
Yes.
And the key here, I mean, the absolute critical piece is that the farmers aren't just suppliers to this system. They are the shareholders.
Yes, that is the defining feature. When Amul sells a block of butter in a supermarket in Mumbai, the profit flows right back down the chain and lands directly in the pocket of the farmer who milked the cow in the form of regular dividends.
Wow.
This structure turned fragmented, impoverished dairy farmers into the direct equity owners of a global dairy empire whose revenues now exceed 1 lakh crore rupees.
Which is what, over 12 billion US dollars?
Exactly.
Okay, so if I take that exact structural template and lay it over the biogas problem, the puzzle pieces just snap together perfectly.
They really do.
A village biogas cooperative forms. But instead of pooling milk, they are pooling biological waste.
Right.
Some farmers might have their own HFN cubes at home, providing their cooking gas. Other farmers, maybe those without the space or the capital for a cube, just bring their raw cattle dung to a large, shared, village-level digester.
Exactly. The cooperative aggregates the outputs.
And this solves the maintenance issue we talked about earlier, right? Because instead of expecting a poor farmer to somehow be a fluid dynamics engineer,
Right, which is absurd.
the cooperative pools its resources to hire and train a dedicated local technician to maintain everyone's cubes.
Yes.
Yeah.
You've completely decentralized the generation of the gas while centralizing the operational expertise.
That's brilliant.
And it gets even more powerful when you look at the economics of procurement. A single farmer trying to buy a biogas cube has very little buying power, right?
Mm.
And they might struggle to navigate complex government subsidy forms.
Oh, for sure. Red tape is a nightmare.
But a village cooperative representing 200 farmers, they have immense collective bargaining power. They can negotiate bulk discounts from the cube manufacturers. They can legally navigate and aggregate government green energy subsidies.
But wait, here's where it gets really interesting. How do they actually generate revenue? Because with Amul, it's obvious. You sell milk, you get money.
Right.
With biogas, the farmer is burning the gas in their own kitchen. Where is the actual cash flow coming from to make this an empire?
Okay, so this is where we move from a microplant to a macro grid. The philosophy here is you profit when you participate. For the individual household, their immediate dividend is the free cooking gas, which acts as direct financial relief from buying LPG.
Right. Money saved is money earned.
Exactly. But not every ounce of gas is needed for cooking, and not all waste is processed at the household level. The village and district-level cooperatives aggregate the surplus raw waste and process it in medium or large-scale centralized digesters.
Ah, so they run their own massive industrial plants alongside all the little household cubes.
Precisely. And in those large plants, they aren't just piping low-pressure gas to a stove. They apply industrial scrubbers to remove the carbon dioxide and the hydrogen sulfide, effectively purifying the methane.
Right.
They then compress it to incredibly high pressures, creating what is known as compressed biogas, or CBG.
CVG.
Right. And CBG has the exact same calorific value as commercial natural gas. The cooperative can now inject this CBG directly into the national energy grid or sell it as a premium vehicle fuel for trucking fleets and city buses. They basically become an energy utility.
That is wild. You essentially turn the individual farmer into an independent mini utility company.
Yes.
You are sitting on your farm, and you are simultaneously an energy producer, cutting your own utility bills, while holding an equity share in a massive national grid that is literally selling fuel to transport fleets.
It's an incredible shift in power.
And from a financing perspective, the sources note that the initial cost of the cube, like if a farmer wants one at home, is financed through a microloan from the cooperative itself.
Right.
Because the farmer is no longer buying expensive LPG cylinders, they just take the money they would have spent on fossil fuels and use it to pay back the cooperative loan. And the math says it takes only 2 to 4 years to completely pay off the asset.
That's it.
After that, it's pure profit and free energy for the life of the cube.
It is a brilliantly designed closed loop. And, I want to pause here to address an engineering debate that often comes up in this space.
Huh?
Yeah, if you talk to a traditional energy economist, they will argue that building millions of tiny plastic cubes is wildly inefficient.
Okay, why?
They will tell you that large, centralized biogas plants are technically superior. Economies of scale dictate that a massive, multi-million-dollar plant can afford advanced sensors, better thermal insulation, and highly efficient purification systems.
And, I mean, they aren't wrong, technically speaking. Centralization is usually more efficient.
Right. From a pure thermodynamic perspective, yes, they are right. But from a socioeconomic perspective, pure centralization is a complete disaster for the Global South.
Why is that?
Because if you only build massive, corporate-owned, centralized plants, you entirely strip the smallholder farmer of the economic upside. The farmer just becomes a supplier of cheap raw waste.
Oh, they revert right back to being the exploited dairy farmer before Amul existed.
Exactly.
The corporation extracts the value of the CBG, and the farmer is still stuck buying expensive LPG for their kitchen.
You nailed it. This is why the sources advocate so strongly for a hybrid model. The decentralized household cubes provide the rapid, immediate wins, the eradication of kitchen smoke, the instant financial relief, and crucially, a deep psychological sense of ownership.
Right, the farmer owns the means of production.
Yes. Meanwhile, the cooperative structure manages the medium and large plants at the district level to process the surplus for grid injection.
Yeah.
You capture the social equity of the microscale and the industrial efficiency of the macro scale.
Okay, but there's a massive hole in this analogy, though.
Let's hear it.
Amul collects milk, processes milk, and sells milk. It's a very clean line. But with biogas, the cooperative is collecting dung, taking the gas. But they are left with thousands of liters of thick black sludge draining out of the bottom of these cubes every single day.
Yeah.
The gas bubbles up, but what do they actually do with the waste from the waste?
Well, that waste from the waste, as you call it, is arguably the most valuable part of this entire system. Yes, it is called digestate. And to understand why it is so critical, we have to pivot and look at a silent, creeping crisis that threatens our very ability to survive on this planet. We really need to talk about soil.
Let's do it, because when we talk about climate change, we always talk about the atmosphere, right? We talk about carbon in the air. We rarely look down.
And we desperately need to look down because the agricultural landscape of the Global South is facing severe existential degradation.
Okay.
For the last 60 years, essentially since the Green Revolution, we have engaged in incredibly intensive extractive farming. To maintain crop yields, we have heavily subsidized and relentlessly applied synthetic chemical fertilizers.
Primarily nitrogen, phosphorus, and potassium.
Right.
NPK.
Exactly.
Yeah.
We're talking about massive applications of diammonium phosphate or DAP and urea.
Now, I think most people assume fertilizer is just food for plants. You put it in the dirt, the plant eats it, the plant grows. What is the actual problem with that?
The problem is that soil is not just a sterile sponge holding chemicals for roots to drink. Healthy topsoil is a hyper-complex living biological matrix.
Right.
It is packed with fungi, nematodes, bacteria, and earthworms. These organisms create the physical structure of the soil, allowing it to hold water and naturally cycle nutrients.
Okay.
When you constantly dump synthetic urea and DAP onto a field, you are essentially dumping concentrated salts. This creates a massive osmotic shock to the microbiome. It desiccates and kills the living biology of the soil.
So it's basically salting the earth.
Literally. Over decades, the soil physically collapses. It loses its porosity. It turns into compacted, lifeless dirt.
Wow. And to put some terrifying numbers to this, the sources cite a metric regarding soil organic carbon, or SOC.
Right.
SOC is essentially the measure of life and organic matter in the dirt. And the data shows that in the tropics and subtropics, the annual global topsoil SOC is declining by an estimated 1.9 petagrams.
Now, a petagram is an incomprehensible number for most people.
Yeah, what is that?
A single petagram is 1 billion metric tons.
So, we are losing nearly 2 billion metric tons of organic carbon from our topsoil every single year in these regions.
Yes, we are bleeding carbon from the earth. And when soil loses its organic carbon, it loses its cation exchange capacity, which is its ability to hold on to nutrients and water.
So it's just dead dust at that point.
Basically. So what happens? The farmer applies more chemical fertilizer to overcompensate, but because the soil is dead, it can't even absorb it. The fertilizer just washes away in the next rain, polluting local waterways and causing massive algae blooms, while the crop yields inevitably plummet anyway.
I picture the global soil crisis like a massive shared bank account.
That's a good way to look at it.
For decades, we have only been making withdrawals. We withdraw nutrients, we withdraw carbon, we withdraw water to grow our food, and we've tried to prop up the balance with artificial credit, meaning chemical fertilizers.
Right.
But the principal balance is gone. The account is totally overdrawn. And this is where the digestate, the sludge draining out the bottom of that plastic biogas cube, comes in.
It is the ultimate deposit back into the Earth's account.
How does it work?
Remember the biological disassembly line we talked about inside the digester?
Yeah, the 4 stages.
Right. The microbes consumed the volatile fatty acids to make the methane, but they did not consume the core elements of nitrogen, phosphorus, or potassium.
Oh, interesting.
In fact, the anaerobic digestion process actually mineralizes these nutrients, converting them into forms that are immediately bioavailable to plant roots.
So it's an incredibly potent fertilizer, but unlike raw manure, it's safe.
Exactly. Because if you just dump raw, fresh cow dung onto a field, the nitrogen is volatile and off-gases into the atmosphere as ammonia. Plus, it's full of weed seeds and harmful pathogens.
Which you don't want on your crops.
No. But because the digestate has sat in a sealed, oxygen-deprived environment for 30 days, the weed seeds are destroyed, and the pathogen load is decimated. You are left with a premium, nutrient-dense, biologically active organic fertilizer.
And the sources note that when farmers take this liquid digestate and apply it back to their depleted fields, the results are deeply measurable.
Oh, very much so.
It physically rebuilds the soil structure. It acts as a biological inoculant, kind of waking the soil back up. It improves water retention dramatically, which is absolutely vital in drought-prone areas.
Yes.
And they cite that it boosts crop yields by 10 to 20% in these heavily degraded soils. Plus, you are sequestering carbon right back into the ground where it actually belongs.
And if we zoom out to the macroeconomic level, closing this nutrient loop has massive implications for national sovereignty.
How do you mean?
Well, many countries in the global south, including India and several African nations, spend a huge portion of their national GDP subsidizing and importing chemical fertilizers.
Right.
They are heavily dependent on global supply chains that are wildly vulnerable to geopolitical shocks. I mean, look at how fertilizer prices spiked recently due to international conflicts.
Right. So by utilizing digestate, you are essentially replacing a massive, expensive import bill with a homegrown, infinitely renewable resource.
Exactly.
You save billions in foreign exchange reserves, and fundamentally, you are securing the actual foundation of your food supply. I mean, it is the only mathematical way we are going to feed a growing global population without resorting to cutting down the Amazon or the Congo Basin just to find fresh soil.
It really is.
Okay, so if I pause and look at what we've covered so far, we have solved the rural energy crisis. We are saving hundreds of thousands of lives from indoor air pollution. We've built a decentralized economic empire using the Amul model, and we are literally healing the biological fabric of the Earth's topsoil.
Right.
Not bad for a plastic cube, but I have to throw a massive wrench into this.
Go ahead.
This entire model relies on cow dung.
Yes.
It's great if you are a rural farmer with 2 cows, but the reality of the global south is rapid, unrelenting urbanization. Millions of people are leaving the farms and moving to megacities, Mumbai, Lagos, Nairobi, Dhaka. They live in dense apartment blocks or sprawling informal settlements. They don't own cows.
Right, they don't.
If this revolution requires livestock, does it just hit a brick wall at the city limits?
It doesn't hit a wall. It actually encounters a much larger, much more concentrated feedstock. We just have to flip the script on what we consider waste.
Okay.
The sources make a fascinating pivot here from the rural dung problem to the urban sanitation crisis. Because at the end of the day, from a biochemical perspective, organic waste is organic waste.
Wait, you're talking about sewage, human waste.
Yes, I am. And the scale of the urban sewage crisis is almost apocalyptic. India's cities and cities across the developing world are facing a severe sanitation nightmare.
Yeah.
Currently, massive amounts of untreated or poorly treated sewage are discharged directly into municipal waterways. If you look at the pollution crises of the Ganga and Yamuna rivers in India, they are literally choked with thick, toxic foam.
I've seen the pictures. It's awful.
It is. The biochemical oxygen demand, or BOD, in those rivers is off the charts because the organic matter in the sewage consumes all the oxygen in the water, killing all the aquatic life.
The sources cite that across the global south, an estimated 62% of urban sewage is unsafely managed.
52%.
It's a staggering public health failure.
It is. But the urban biogas model takes the exact same anaerobic digestion chemistry we just discussed and applies it to municipalities. Sewage treatment plants, or STPs, can be retrofitted with massive industrial digesters.
So treating human waste exactly like cow waste.
Yes. Instead of viewing sewage as a toxic liability that we have to spend millions of dollars trying to neutralize, we view it as a high-yield biological feedstock. And math is highly compelling here.
What are the numbers?
The sources state that human feces alone produce about 0.4 cubic meters of biogas per kilogram.
Wow. Okay, the math works. The chemistry is exactly the same as the rural model. But I have to push back here because this is where the theory hits human psychology. Let's be brutally honest. Are people actually going to accept this? Are residents in a city going to be comfortable turning on their stove to cook their dinner, knowing the gas is derived from their neighbor's flush toilet?
Right.
Or buying tomatoes grown with fertilizer made from urban sewage sludge? There is a massive visceral yuck factor here.
The yuck factor is very real, but it is entirely psychological, not scientific.
Okay.
And we overcome it by understanding the sanitation process. And anaerobic digestion isn't just an energy process. It is one of the most effective sanitation technologies ever developed.
Really? How so?
When you take raw sewage and hold it in a sealed, temperature-controlled digester for 20 to 30 days, the biological environment is incredibly hostile to human pathogens.
Okay.
The bacteria and viruses that make us sick, cholera, typhoid, dysentery, they require oxygen and specific host environments to survive. In the digester, they are systematically outcompeted and destroyed by the methanogens.
Oh, wow. So the digestate coming out the back end is chemically safe to use on agriculture?
Yes. When properly managed, it is safe, sterile, and nutrient-rich. And as for the gas, methane is a pure chemical compound. One carbon atom surrounded by 4 hydrogen atoms, CH4.
Right.
It does not carry the memory or the odor of its origin. Methane is methane, regardless of whether you extracted it from a fossilized dinosaur bone deep underground, a cow's stomach, or an urban sewage plant. It burns perfectly clean.
That makes logical sense, but it's still a tough sell.
Well, organizations like Sulab International in India have already proven this concept. They have successfully run biogas plants fed entirely by public toilet complexes for years.
Oh, wow. I didn't know that.
Yeah. Modern STPs can capture this gas, use it to generate electricity to power the treatment plant itself, which makes the sanitation process carbon neutral, and compress the surplus into CBG to run the city's bus fleets.
So it's largely an education problem. We just have to convince people that the chemistry is sound.
Well, what's fascinating here is you don't convince people with chemistry lectures. You convince them with economic incentives.
Ah, of course. Money talks.
Exactly. You take the Amul cooperative logic we discussed for the villages, and you adapt it into an urban public-private partnership, or PPP.
Okay, how does an urban cooperative actually function, though? Because the residents don't own the sewage plant, right? The city does.
They don't own the plant, but they can own shares in the outcomes. Imagine an urban waste cooperative formed jointly by the municipality and resident welfare associations.
Okay.
This cooperative manages the upgraded sewage treatment plant. The STP generates significant revenue by selling compressed biogas to the municipal transport grid and selling that safe, high-volume organic fertilizer back to the rural farming cooperatives we talked about earlier.
Wait, I love that. So the city is exporting fertilizer to the country, and the country is exporting food to the city. That's a beautiful loop.
It really is.
But how does the individual apartment dweller get their dividend? In the rural model, they got free gas. What do urban residents get?
The urban residents participate in the cooperative by doing two vital things: properly segregating their solid organic waste at the source and ensuring their homes are legally and properly connected to the municipal sewer system.
Which is actually a massive challenge in informal urban settlements.
Exactly.
Yeah.
If a neighborhood meets compliance, their dividend is distributed not as direct cash, but as steep reductions in their municipal sewage and property taxes.
Oh, that's smart.
Right. The cooperative can also route profits into direct funding for community projects, parks, schools, street lighting, or issue tradable green credits. We are literally taking a toxic liability that destroys rivers and spreads cholera and turning it into a localized wealth-generating asset that pays citizens for responsible sanitation.
That is a masterclass in behavioral economics. You align the financial incentive directly with the civic duty.
Absolutely.
So we have built the rural model, we have built the urban model. It's time to zoom out, because this deep dive, while heavily anchored in the Indian context, isn't just about India.
No, it's not.
The sources broaden the scope significantly to the entire global south. We are talking about sub-Saharan Africa, Latin America, Southeast Asia, and the potential numbers here are almost hard to comprehend.
They are staggering.
Yep.
The International Energy Agency estimates that the sustainable biogas potential globally is nearly 1,000 billion cubic meters of natural gas equivalent.
1,000 billion.
Yes. To put that in perspective, that is roughly equal to 25% of total global natural gas demand.
A quarter of the world's gas demand.
And the critical geopolitical point is that 80% of this potential lies in emerging and developing economies.
Right. And the sources put it in incredible human terms, too. They state that globally, livestock manure alone, just the dung, could generate enough electricity to power 330 to 490 million people.
Just from manure.
Think about the vast cattle herds traversing sub-Saharan Africa, or the immense agricultural residue generated in Latin America. The fuel to power these continents is literally just sitting there. It is rotting in fields, emitting raw methane directly into the atmosphere, which is a greenhouse gas 80 times more potent than CO2 in the short term, while millions of people in those exact same regions suffer from crippling energy poverty.
It is a profound market failure. The resources are there. The technology, the HFN Cube is there.
Right.
But here is the ultimate hurdle, and the source material tackles this head on.
Okay.
The Amul cooperative model is mathematically beautiful, but it relies on deep social trust. Building grassroots cooperatives, village by village, district by district, takes an agonizingly long time. India spent half a century painstakingly building the Amul network.
And if we are looking down the barrel of a global climate crisis, plummeting topsoil reserves, and rampant energy poverty today, we don't have 50 years to wait for organic social trust to form in every village in the global south. We have to speed run this.
Precisely. If cooperatives alone are too slow to scale globally, we need a different mechanism for deployment. And this brings us to the final and perhaps most innovative structural solution proposed in these sources: the corporate cooperative hybrid franchise model.
Right. And to explain this, the sources use an analogy that caught me completely off guard.
It's a great analogy, though.
They ask us to look at fast food franchises like McDonald's, and specifically the Patel Motel empire in the United States.
Yeah.
I didn't know this statistic, but Indian Americans, largely from the Patel community, own roughly 50 to 60% of all motels in the U.S.
Wow.
And they achieved this dominance not through massive corporate buyouts, but through tight community networks utilizing the franchise ownership model.
It is a brilliant mechanism for rapid, standardized scaling. Let's break down how a franchise actually works.
Okay.
In a traditional corporate model, a central company owns every location and hires employees to run them. It requires immense corporate capital and moves slowly. In a franchise model, a central corporation, the franchisor, develops a highly successful standardized system. They perfect the technology, the branding, the supply chains, and the operational playbook. But they don't own the individual stores.
The franchisees own them.
Exactly. Local entrepreneurs, the franchisees, put up the capital, own the local physical asset, and run the daily operations, paying a fee back to the franchisor for the system.
So how do we map the Patel Motel or the McDonald's franchise model onto global biogas deployment?
In this hybrid model, a large multinational corporation acts as the franchisor. This corporation's job is to provide the cutting-edge, standardized technology. They manufacture the millions of HFN cubes. They develop the smart sensors that monitor gas pressure and microbial health. Yep. They provide the blended finance required to kickstart the system, and they establish the overarching brand. But crucially, the corporation also acts as the interface for international carbon credit markets.
Okay, I want to pause on the carbon credit piece because that is a buzzword that gets thrown around a lot. Why does a farmer in Kenya or Peru care about international carbon markets?
Because it is a massive source of revenue. But the barrier to entry is impossible for an individual.
How so?
Well, to sell a carbon credit to a massive tech company in Silicon Valley trying to offset its Scope 3 emissions, you have to prove, with rigorous data, that you actually reduced emissions. This requires complex MRV measurement, reporting, and verification.
Oh.
A single village cooperative running a few dung digesters does not have the legal or technical capacity to hire international auditors, install satellite-linked sensors, and navigate global carbon registries.
It's too complex. It's like asking a single dairy farmer to negotiate an international trade treaty.
Exactly. So the corporate franchisor handles the MRV. They aggregate the data from millions of smart-sensored cubes across the globe, verify the emission reductions, sell the carbon credits on the global market at a premium, and distribute that revenue back down the chain.
Okay, I hear the logic, but I have to throw a red flag here.
Sure. Because historically, the moment you introduce massive multinational corporations into the agricultural systems of the global south, it ends in exploitation.
Yeah, that is a very valid concern.
If corporations get involved as the franchisor, don't we risk them just extracting all the value? Don't we just recreate the exact same predatory dynamic we're trying to escape, where the poorest farmers do all the dirty work of feeding the digesters, and a corporation in London or New York siphons off all the carbon revenue and CBG profits?
That is the exact trap this hybrid model is meticulously designed to avoid, because the foundational rule of this system is that the local farmers and the local cooperative act as the franchisees.
Okay.
They retain full equity and ownership of the physical assets, the digesters, and the land.
Right.
They own the feedstock, they run the daily operations.
Because they own the means of production. They keep the lion's share of the profit from the gas and the fertilizer. The corporation makes its money on volume, a small percentage fee on millions of transactions, selling standardized tech and taking a cut of the carbon credit administration, not by dictating and exploiting the price of the farmer's raw materials.
So it's trying to thread a very difficult needle. It marries the speed, the data management, and the massive capital access of a corporate network with the equitable wealth distribution and local ownership of a cooperative.
Yes. And if you think this sounds like a utopian academic theory, the sources point out that Amul is executing this exact hybrid model right now on the global stage.
Wait, really?
Yeah. Amul recently expanded into the United States market to sell fluid milk. Did they spend billions building their own dairy farms in America? No.
Oh, the sources say they partnered with the Michigan Milk Producers Association, right, which is a 108-year-old American dairy cooperative.
Exactly. Amul, acting as the corporate franchisor, brought their legendary branding, their formulation, and their distribution partnerships, like their deal with Costco.
Okay.
The local U.S. cooperative, the MMPA, handles the actual localized production. The American farmers are protected because they own their farms and their cooperative supply chain, but they are dramatically expanding their market reach by leveraging Amul's corporate distribution framework.
So you take that exact proven architecture and you apply it to biogas in sub-Saharan Africa or Latin America. A corporation rolls out a biogas franchise package. They bring the smart cubes, the financing, and the carbon market access. But the local community cooperatives own the plants.
Exactly.
It ensures corporate speed without sacrificing cooperative equity.
Yes, it's brilliant.
So if I step back and look at what we've unpacked today, I mean, it is an unbelievable journey. We started by looking at a simple 1,000-liter white plastic cube sitting in a courtyard in rural India. We saw how this rugged plug-and-play appliance replaced the fragile, expensive masonry mainframes of the past, democratizing access by lowering the barrier from 5 cows down to 2.
And we explored the complex, multi-stage biology of anaerobic digestion and realized that this isn't just about energy.
No.
It is a massive public health intervention capable of saving hundreds of thousands of lives by eliminating the lethal PM 2.5 smoke of indoor cooking fires.
We looked at how to scale that using the genius of the Amul cooperative model, turning impoverished, fragmented farmers into highly organized energy producers and fertilizer manufacturers, all holding equity in a massive closed-loop system.
Hmm.
We confronted the terrifying, silent crisis of topsoil degradation and discovered how the digestate draining from these cubes is the biological key to restoring billions of tons of carbon to the Earth's overdrawn bank account.
And then we took that exact same biochemical logic and applied it to our rapidly growing megacities. We proved that if we can overcome the psychological yuck factor, we can transform urban sewage from a river-killing, disease-spreading liability into a revenue-generating, city-powering asset through urban municipal cooperatives.
And finally, we looked at how to unleash 1,000 billion cubic meters of natural gas equivalent across the entire global south. By utilizing a corporate cooperative hybrid franchise model, we can leverage the speed and capital of global markets while fiercely protecting the ownership and equity of the local farmer.
It's incredible.
If you are listening to this, whether you care about the minutiae of climate change policy, the macroeconomics of global energy, the public health crisis of the developing world, or just brilliant, elegant systems design, this waste-to-wealth framework proves something profound.
What's that?
The solutions to our absolute biggest, most terrifying crises might not require us to invent magical, undiscovered technologies. The solution might just require a radical new way of organizing the biology that is already sitting right in our backyards.
The historical obsession with alchemy was never really about transmuting lead into gold. It was always about transmuting failing systems into sustainable ones.
That is perfectly said.
Right.
Which leaves us with a final, lingering geopolitical question to ponder.
Let's hear it.
We have established that biological waste, whether it's cow dung, crop residue, or urban sewage, is mathematically destined to become one of the most vital and valuable resources on Earth for both energy independence and agricultural survival.
Right.
If that is true, how will the balance of global power shift when the countries in the global south realize that their massive populations and their vast livestock herds no longer make them dependents of the fossil fuel era, but rather the ultimate energy superpowers of the 21st century?
It rewrites the map.
We'll let you chew on that. Thanks for joining us on today's Deep Dive.